Hello friends, welcome to this another session. Today we are doing physics analysis for the NEET test 58. I have solved it right now. So as per me, this paper is difficult than the previous 2-3 papers. I can regard it 7 as tough. I would regard it 28 as tough because that is a theoretical one, but I doubt how many could answer it comfortably. The answer for 25th is wrong. 11th and 12th may also be regarded as difficult, but I have regarded the medium because the questions are generally being practiced by the students. So this is about the paper. 21 were medium, 17 were easy, 7 were tough. So in this paper, the scores won't be that high that you were getting from the last 2 days. So for the if average student gets even 130 plus, he's doing fine enough, and a score of 155 or 160 plus would be seen as a very good score for me in this particular paper. And today you might feel some discontinuity because of the headphone issue. It was getting disconnected, so I need to be very careful whether it was connected or not. So I've done today in many parts, so you will feel it. So I'm really sorry for that. I'm getting that issue to be sorted out. Maybe my memory of the iPad is full, so that's why that stops. I need to find that issue. So let's start the paper right now. So let's see. First question: X-ray start tube produces a continuous spectrum of radiation with shortest wavelength. The maximum energy of photon in the radiation in EV is. So because we are given the shortest wavelength, so maximum possible energy would be when this complete EV energy get transferred, or the shortest wavelength is transferred. So maximum energy would be this hc upon lambda min. So that's an easy one for you. Without knowing even X-ray, you can attempt this one, I feel. So 1240 eV nanometer, if I convert it 45 into 10 to the power minus 2 angstrom, that means 45 into 10 to the power minus 3 nanometer. So what we have, 1240 upon 45 into 10 to the power 3 eV. So you have to write it in eV, okay? So this is an eV, what we have got. This is 45. This is approximately what we'll do. This is 290, 90, and between 340. 340 is approximately 45, 90. You can have, this is 7. So 27 point something, it would be the answer. So we'll go for 27,500 as per these option. It would be close to 27,500 electronic volts. Okay. Second one, 2 point masses connected by an ideal string are placed on a smooth horizontal surface as shown in the diagram. A sharp impulse of 10 kg per meter per second is given to the 5 kg mass. The velocity of the 10 kg mass will be. So here what we know, along this length of the string, because string is inextensible, both should have same velocity, so relative velocity will be 0. So what I should see, the component of impulse along this direction, that I'll write at I cos 60, because both will move together, I can directly write it as 15v. So v, because this will only have v, it will have some component there, but it will only have along the length of the string, so that v would be I cos 60, that is 10 into 1 by 2 divided by 15. So what we have now, 5 by 15 or 1 by 3. So 1 by 3 meter per second, go for option B. Next, third one. A car turns on a slippery road at a constant speed of 10. The coefficient of friction is 0.5. The minimum radius of the arc in meter when the car turns. So what we have here, that complete centripetal force is provided by Fs, which should be less than equal to mu Sn, and N is mg. So limiting case, what we will have, mv square by r less than equal to mu smg. So r should be greater than equal to v square by mu sg. So that is 100 upon 0.5 into 10, that is 5. It comes out as 20 meters. Go for option A. Now, going for the next one, question number 4. What we have? At temperature of 30, the susceptibility of the paramagnetic material is X. Its susceptibility at 333 is. So 30 means what we have? 3 is 0, 3. 333 means plus 273 is 606. So it is what we have, temperature is doubled. So the chi definitely is going to be half, because chi is half, because chi is inverse to t. So it was x, it will become 0.5x. You can directly go for it. Next, a wire made of aluminium has resistivity this, radius this, current of 5 ampere flows through the wire. If the potential difference is 1, the length of the wire. So it's simple Ohm law, I suppose. V equal to IR, and R you know is rho L by A is pi r square. So what is the length? V into pi r square upon I rho, substituting value 1 into pi r square. R square is what? Radius square, 4 in 10 to the power minus 6. I is 5. This is 2.8 into 10 to the power minus 8. So if I do this, this becomes 100 into 4 pi, and this 2.8, 28, 5 is 140, that is 14. Okay, so this is 400 pi by 14. So it would be greater than 1200 something upon 14. So 14 9 is 126, so it would be closer to 9, so it would be 90. That should be the option I should go for. So this was question number 5. Now question number 5. So the power dissipated in the adjacent circuit is. So looking at this circuit, this is R, this is root 3R. First of all, let me find Z. Z would be R square plus XL, C minus XL whole square, that is 3R minus R whole square, that is 2R whole square. So what we have, root 5R. So I can directly find out IRMS. IRMS would be V naught by root 2 VRMS upon Z root 5R. Now power dissipated is only resistor dissipates power, that is I square R. So if I do this, if squaring the above term, V square naught square, 2 and 5 becomes 10R square into R, so it becomes V naught square by 10R. So going by the option, it should be D. Next one. Two concentric conducting spheres of R1, R2 carries plus Q minus Q. Region between the spheres filled with two insulating layers of dielectric epsilon 1, epsilon 2 with D1, D2. Variation of the potential and field is given. Select the correct one. Assume potential V at R2 equal to 0. Okay. So first of all, okay, V at R2 is 0, so this is wrong because here R2 is not 0. Plus what I can say, in this region field is 0 and V should be constant. So let me check. First one is wrong because V is varying. Here E is 0, this is also wrong. Here E is again non-zero, it is also wrong, so only this is the left option, and we'll have this potential will be constant, and here it will decrease, here it will decrease, and decrease will be with slightly some different because of K. So option C seems to be the most appropriate one. So question looked up tough, but it turned out to be easy. Next one. Two identical satellites moving around the Earth in circular orbit 3R and R, where R is the radius of the Earth. So this is height. So the radius becomes 4R and 2R. So that means this has the double radius, and we know kinetic energy is inverse to R. So because radius is doubled, its energy would be halved. So it will have the more energy and the ratio would be 2, or you can say for this we should have 1:2. So go for option B. So just remember we have to put that formula of K, that is mod of E, that is GMM by 2R, and that R is equal to R plus H. So don't get confused. Next one. Body cools from 50 to 14.5 and then to 33.33 in next 5. The temperature of the surrounding theta is okay. Let me have it plot over here. So 50 to 40, it comes in 5 minutes, okay, and next 5 minutes it comes to 33.33. Better I should write it as 100 by 3. That would be more appropriate for me now. So applying Newton's law of cooling in approximate version, let's say from A to B and then from B to C. So first A to B. What is the change in temperature? 10 divided by time, which is 5 minutes. That is K times average theta. What is the average theta between 50 to 40, 45? Minus theta is first equation. For B to C, 40 to 33.33, 6.667. So what we can have, or for 40 minus 110, 100 by 3, that comes out to be 20 by 3 is the change. Time is 5 minutes. And K, what is theta average? So 100 by 3 plus 40 divided by 2, what we will have, 120, 220 by 3, so 220 by 6 or 110 by 3 I should write. So now divide the both, what we will have, 10 upon 20 by 3 equals to 45 minus theta s upon 110 by 3 minus theta s. So let it be 30 above, so 30 into 110 by 3 minus theta s is 20 into 45 minus theta s, not theta 3, this is theta s, okay. So what you will have, this is 110 minus 30 theta s, 900 minus 20 theta s, so take it there, 20 theta s, okay, I should write like that. Go to 10 theta s, it will become, it is not 11, it is 110, sorry, that 0 I missed, so that is equal to 200, so theta s comes out to be 20 degrees Celsius. So go for option B. Now, when water is converted into ice, so when water is converting into ice, you know the state water has more disorder, ice has less disorder, so entropy should decrease. So entropy should decrease, and that should be the answer for you. For the reverse ice to water, it would have increased. Next one. So it's a theoretical one for you. You study it in chemistry basically. The length L of wire carries a current I, steady current I. It is bent first into a circular plane coil of 1 turn. The same length is now bent more sharply to give 3 turns of smaller radius the magnetic field. This is a very standard question. I simply say my students to remember this B at center will depend on n square, and the magnetic moment depends on inverse of n. So as you increase the turns, the B at center will increase by n square, but the magnetic moment decreases. So because it is proportional to n square, this becomes what we'll say 9 times of its initial value. If you want to derive it, no issue. B at center, what's the formula? The formula is mu naught Ni by 2r. And what is r? We say n into 2 pi r would be equals to L. So R is what? L upon 2 pi n. So if you can do this, you directly comes out to be proportional to n square. Similarly, check for magnetic moment of the coil. It is also inverse to n. So it's a standard result. You should remember. I always say my students to remember. The next one. At the same instant, two boys throw balls A and B from the position shown for speed V0 and KV0. Okay, where K is a constant, for what value of K balls will collide. Okay. So for balls to collide, you can see they start from the same x and they should end for colliding, the x and y both should be same. The first thing is, because initial x is same, final x is same, there's no acceleration in x, so it means UAX should be equal to UBX, I should write. So for this one, what is the x component? This would be, because theta is with the normal, with the vertical, it is V naught sine theta by 2, and this would be, because it is with horizontal, KV naught cos theta 1. So from here, what we are at, K is equal to sine theta 2 upon cos theta. Oh, it turned out to be an easy one. I thought it should be some difficult one, but it simply happened by just the first condition, so it's good. Go ahead. For the system shown in figure, the inclined plane is fixed and the pulleys are light and friction is absent everywhere. The tension in the string will be, okay. So what will be the tension in the string will be, and you need to find out. So first of all, because it is fixed and there is no friction, so this is going to pull it down. And what we'll have, if I write the equation, let's say I write basic equation, I'll write mg sine theta minus t, that is equal to ma. If this goes with a from constraint, it goes with a here, and this t will be here, so t would be equals to again ma. So adding it, what we'll have, mg sine theta is equals to 2ma, acceleration is equal to mg sine theta by 2m, that is g sine theta by 2. So what is tension? Tension would be half of the mg sine theta, so it goes by option C. You can go to not that difficult one. Now go for the next one. Which of the following plot is correct about Maxwell's speed distribution law? So you know that law is at very low speed it is 0, at very high speed it is 0. Plus what we know, what we know that if you do that averages now, so what we have, if you can remember, VRMS, that was root 3 RT by M. V average, what you had that root 8 RT by pi M, and for the V most probable you had that root 2 RT by M. So VMP is the most least one and VRMS is the highest one, and V most probable is that this peak. So this is wrong. This is most probable, but average is given lesser, so it is also wrong. So this is also wrong because URMS is lesser, so definitely this is going to be right. So option D, go for option D. So it's a straightforward question. You need to be careful about figures. Don't go fast, just check it. Next. Two masses are connected together by a massless spring of constant K. When the masses are in equilibrium, M1 is removed without disturbing the system. Find the angular frequency of oscillation of M2. We know angular frequency depend on what is the system is left. So omega will simply be root of K by M2. It now doesn't depend on M1 because M2 is only dancing. So it would be A. Interesting thing would be, that's an exercise for you. Tell me what would be the amplitude of the SHM. You should try to find it out. Next one. Light of energy 2 eV falls on a metal of work function 1.4 eV. The stopping potential is no need to solve it here. 0.6 voltage. There's no point in discussing it. Go ahead. Next. The level of water in a tank is 5 meter high. The whole of the area 10 centimeters square is made in the bottom of the tank. The rate of leakage of water, so that dV by dt you know is equal to A into V, and AB is equal to root 2 GH. So what you have, 10 centimeters square, 10 into 10 to the power minus 4, root 2 into 10 into 5, so that comes out as 110. So that is 10 to the power minus 2 meter cube per second in SI unit. So go for option A, again an easy one for you. Next one. Prism has a refracting angle of 60 degree. When placed in position of minimum deviation, it produces a deviation of 30 degree. The angle of incidence is, we know delta minimum is equal to 2i minus a, because I is equal to a. So you know a, you know deviation, so 2i would be equals to 60 plus 30, 90. So I is 45. I think this question is getting repeated. We have solved such question in one of the tests before. Neat. Solid sphere, hollow sphere, same mass. and radius are given a spin about the cm, and then they are placed on a rough horizontal surface. The spin angular velocity is same and is equal to omega naught. Once the pure rolling starts, let v1 v2 be the linear speed of their center of masses, then what will happen? So just in such questions, you just remember you have just to spin it, let's say like this, omega naught. So about this initial point of contact P, finally I can say when it comes to pure rolling V and V by R, we know angular momentum about P remains conserved because the friction whether acts here or here there, they definitely here it is going to act here, and the normal and mg all talks about point P is 0. So equating that L, so first of all about initially it is only ICM omega, so it would be I omega, and finally it would be equal to I about Cm plus mr square, because Ip into omega generally we write, or you write it as V by R if you remember directly. Now this question will be done only when you have done such questions before. Okay, so V what we get is I omega R upon I plus mr square. So what we have, this is omega R, and I have 1 plus m by I r square. Okay, and I what we write as mk square, so it is omega R, or I should write it as omega R upon not beta 1 plus r square by k square. So simply the one which has k lesser, the one which has k lesser will have this term greater, and therefore v would be lesser. So v would be less for what we can say less k. So the one which has more k will have more v. So which has the more k, the more k is for, we know, for the hollow one. So hollow one will definitely have the better speeds. So go for the hollow one, that is v2 will be greater than v1. That is what we can make it out. So that is the result that we can. You call this k as a radius of gyration. If you get confused, I am telling you again, k is radius of gyration, which we say k square is 2 by 3 r square for the hollow one and 2 by 5 for the solid one. Next one, 20th one. If we add impurity to a metal whose atoms also deflect electrons, therefore what will happen? The electrical and thermal conductivities both increase, both decrease. Electrical increases, thermal decreases, electrical decreases, but thermal increases. So this is a question perhaps I have seen in some VIT paper before, and this question confused me then also. Simply the reason here we say is because the number of electrons will increase, their collisions will increase, so both conductivities are going to decrease. That is, you can remember. Next one, 21st. Two vessels separately contain two ideal gases A and B at the same temperature, the pressure of A being twice that of B. Under such condition, the density of A is found to be 1.5 times the density of B. The ratio of their molar weights is. Okay, so two vessels separately contains two at the same temperature, pressure of A being twice. So we don't know about the volume, but because of density, I know that form of ideal gas law Pm not equals to rho RT. So I'm given what we have given, temperature is given, the pressure ratio is given, and the what is given, and the density is also given. The molar mass ratio I can directly say m naught A upon m naught B, or mb naught, whatever you write, that would be equal to rho A upon rho B into Pb upon Pa, I should write. So rho A upon rho B is 1.5 and Pb upon Pa, that is equals to 1 by 2. So it comes out as 3 by 4. So go for option A, not a tough one, simple application of your ideal gas equation. Next, which of the following physical quantities are neither unit nor dimension? Not dimension nor unit. Angle has a unit, luminous intensity has both, coefficient friction doesn't have anything, so this is the correct option. Now, next. Ratio of intensities in consecutive maxima in a diffraction pattern due to a single slit is. Now this is basically out of syllabus. What thing you can say, typically this is not taught to you, but again you can remember this. We write this I naught sine alpha upon alpha whole square, very famous formula for here, and we have this maxima at alpha equal to 0, then at 3 pi by 2, then at 5 pi by 2, and so on. So for the first three, for the first one at 0, what we have, sine 0 by 0, that we approach as 1, so you can directly write that, sorry, sine alpha. So 0 by 0 will be that form approaching 1, you can know that is I naught, that is the maximum for 0. No point in putting in the formula, check it for 3 pi by 2. So sine 3 pi by 2 is 1, and this would be 4 by 9 pi square, that you can directly say, and here it would be 4 by 25 pi square, you can make it out from here. So go for option D. So just remember this thing also, generally not taught, but the question has come, so we can't help. Next, Two uniform wires of the same material vibrating under the same tension. The first overtone of the first wire is equal to the second overtone of the second wire, and radius of the first wire is twice the radius of the second wire, then the ratio of the length of the first to the second. Again, I think such question we have done before. So they have same material, same tension. Okay. So what is the frequency? Is the fundamental frequency F naught, if I write, is V by 2L, and V is root of T by mu. Mu is rho times A upon 2L. So it T is same, rho is same, so 1 by A, so it basically comes out to be 1 by RL. That is the basic result for F naught. So now what we have, first overtone of the first wire. So first overtones means V by L. V by L means, if I write it as 2 times, let me write by T by rho pi, and let me have it as 2 R1 L1. Okay, that would be equals to the second overtone of the second wire. Second overtone means 3 times T by rho pi. This factor is same. This would be 2 R2 L2. Okay, so this get cancelled. So what we have now, we have to find the ratio of the lengths. So L1 by L2, that is going to be 2, 2, 2, 2 cancel. This would be 2 by 3 times R2 by R1. And what is R2 by R1? Radius of the first is twice. So this is 2 by 3 into 1 by 2. So it comes out to be 1 by 3 as per me. So I should go for option A. Yes, that's the right one. Next way. The potential energy of the system increases if work is done. So work is done upon the system by a non-conservative force, by the system against a conservative force, by the system against a non-conservative, by the system by a conservative force. So what we know, if the conservative force does positive work, potential energy decreases. So we should go for one is the upon the by the system against a conservative force is okay. We have to be very careful. Just to help you out. Let's see. If I put this, take this block upwards, definitely its potential energy increases. In that case, this is mg, so the work done by mg will be negative, so our system has to do the work against the conservative force, so the logic should be upon b and d, it should be b. So clearly, as per me, answer given is wrong. I will go for option b. I don't go for option d as given in your answers. Next, particle A has a charge q, particle B has charge 4q, with each of them having the mass m. When they are allowed to fall from rest through the same potential difference, the ratio of their speed will be. So what we'll have, because same potential difference, its energy would be qv would be equals to half mva square, and that would be 4qv is equal to half m vb square. So if you do this, so va square by vb square comes out as 1 by 4, so va by vb would be 1:2. So not a tough one for you. Go for option C. Next, hammer of mass m strikes a nail of mass small m with a velocity 20 meter per second into a fixed wall. The nail penetrates up to the depth of 1. The average resistance of the wall to the penetration of the nail is. So simply, first of all, when it hits, we treat it as a perfectly elastic collision. So m into 20 will first be equal to m plus m into v. Okay, now this velocity is being let's say taken away by that resistance, so the loss in energy would be half m plus m into v square. That should be equal to f into s, so that f would be equal to half m plus m into v square. So m plus m into v square, if I do, this is m plus m v square. If I do, that is 400 m square upon m plus m whole square, and if I divide it by s, let's say like this. So now this m plus m 1 power goes. So now what we have, let m square upon m plus m I can write here, and what we'll have now, 400 upon 2 into 1, 1 in means 10 to the power minus 2. So what we have, this is 200, so this is 2m square upon m plus m into 10 to the power 4. So for me, the option 4 B seems to be the most appropriate one. Next one. Next one, consider the Earth as a uniform sphere of mass and radius r. Imagine a straight, smooth tunnel made through the Earth which connects any 2 points on its surface. Remind time that a particle would take to go from one end of the other through the tunnel. This is a very famous question you must have done in your notes. What we have, the logic is, if you dig this tunnel, the particle, if you let's say displace it here, it undergoes SHM, and SHM doesn't depends on the amplitude, time period plus the location of the tunnel, whether it is here or it is here, and we know that time period is equals to, everyone know, that is equal to 2 pi under root r cube by gm. Now time taken to go from here to here, that would be not full oscillation, that is half of the acceleration, so that time is going to be half of that, that is equal to pi r cube by gm. You can see that derivation anywhere, is generally remembered by students, so I'm doing it on that basis only. Next, Bar magnet has a magnetic moment this, if its magnetic length is 5, its pole strength is. So simply going by the analogy of that electric dipole, we can say its pole strength, whatever we write it as small m or p or whatever you write, that would be magnetic moment upon L. So magnetic moment is 10, this is 5 into 10 to the power minus 2. So it is 1000 by 5 comes out as 200 ampere meter, go by this. Next. In a potentiometer experiment, the null point is obtained at a particular point for a cell on potentiometer wire x centimeter long. If the length of the potentiometer wire is increased without changing the cell, the balancing length will, okay. If the length of the potentiometer wire is increased without changing the cell, the balancing length will. So what will happen if you increase the L, X will decrease, and definitely that balancing length has to increase for sure. So go for option. Okay, so this is you can do next one. A uniformly wound solenoid coil of self-inductance, this resistance is broken into two identical coils. These are then connected in parallel across a 12-volt battery of negligible resistance. The time constant for the circuit is. So it becomes like something like this. This is the first one and this is the second one. So this is the circuit. So first of all, because it is broken, it is 3 3, and this would be zero point 0.9 into 10 to the power minus 4, zero point 0.9 into 10 to the power minus 4. So we can directly draw the equivalent here. So the equivalent way, if I do, the L equivalent will be, because they are in parallel, they add like resistors, so it becomes half, 0.45 into 10 to the power minus 4. The R equivalent also becomes half, you know, that is equal to 1.5. So the effective time constant that you always write, that will become L equivalent upon R equivalent, that is 0.45 into 10 to the power minus 4 upon 1.5. So this comes out as zero point 0.3, zero point 0.3 into 10 to the power minus 4, or 0.3 into 10 to the power minus 4 second, that is a time constant. So go for option C here. Going by that analogy, you can directly do. Next, two identical metal plates are given positive charges Q1 and Q2. Q2 is lesser. If they are now brought close together to form a parallel plate capacitor with capacitance C, the potential difference between them. Now very important. Now they are bring closer. This Q2 is greater. Let's say this is Q1. Let's say this is Q2. By that the analogy that we know, this is clear. On this plate, the charge would be on this surface would be Q1 plus Q2 by 2. This would be Q1 plus Q2 by 2. And on this surface would be Q1 minus this, that would be Q1 minus Q2 by 2, and on this surface it would be minus of Q1 minus Q2 by 2. So now the electric field in between region will not be because of these two, because these two will cancel out. The field is only because of these. So effective charge of capacitor is now Q1 minus Q2 by 2. So you can directly write the potential difference would be equal to that effective Q of capacitance by C, that is Q1 minus Q2 by C by 2C. Sorry, that should be the answer. So go for option D. It's a general question you must have done. Question is very good, but generally we do some sort of such things in our practices. Next, the weight of the body at an earth surface is W at a depth halfway to the center. We know halfway to the center, it going down, G is equal to G naught 1 minus D by R. So you have gone halfway, so that weight will also become halfway. Next way. Metal rod of Young's modulus Y alpha is held at two ends such that length remains constant if its temperature is used by the thermal stress. So length remains same, so delta L due to temperature plus delta L due to stress should be equal to 0. So alpha L delta T plus delta L due to stress, that we write is at simply delta L is equal to FL upon AY, that is TL upon AY, that should be equal to 0. So what you need to know, the tension developed or the stress developed T by A would be equals to minus alpha Y delta T. That is going to be the answer. Delta T means the temperature change. So this is alpha Y small t. That is what we can write. Go for option C. That is the appropriate one. Now going ahead, 35th. A thermodynamic system undergoes cyclic process. Work done by the system is, again, this is a very common figure. What do you see? The work done from A to B, that would be positive, and how much it is positive, and then CD is also positive, so this is also positive, but AD and CB are negative. So what we have, this area we are coming 2 times, and this area, this is 1 times, and this is coming out as 2 times. And from symmetry, for CB, this is 1 time area, this is 2 times area negative, this will be cancelled, and 1 time this will be cancelled. And for DA, this will be cancelled, and this 1 and 1 will also be cancelled. So if you do the calculations, the positive and negative areas get cancelled up. Check it for yourself, answer will come out to be 0. Next. Now here what we have, charged particle enters the region of uniform magnetic field B and is deflected distance D after traveling a horizontal distance A. The magnitude of the here, let me first take this. It goes like this, like this, like this. This distance is d, this distance is a, this is the hypotenuse, and now it goes with velocity something like this. And if I connect to the center, it would be something like this. It would is connected to the center. Let's call it as the radius, because radius is momentum by qb. That will help me in determining what I want to determine. And I know the line joining the center to the midpoint is perpendicular bisector for the chord. So let me call it as pq, and let it call to be, let's say, m. Okay, so pqm, that is what I am having. So this is r and r. Now what to do now? First of all, get some relationships. So what I can do, this length for this triangle I can see. So first of all, length PQ is under root of a square plus d square. And here, if I call this angle as theta, I can write it as sine theta or cos theta. It would be cos theta better, because this is the forming as base. So cos theta, I can write it as, what I can write cos theta as, this is PQ by 2, that is half of under root of a square plus d square divided by r. That is what I am getting. So I need to calculate this value of cos theta. Now, because this angle is theta, I am given, so this whole angle now will be pi by 2 minus theta, because velocity is horizontal. I am not drawn it correctly. If I draw it properly, it would be exact vertical going. Take 1 minute. It would be going exact vertical like this. So it would be 90 degrees, so 90 minus theta, pi by 2 minus theta. So here what we have, if I write it as now, if better I should write it as cos sine 10, I can write anything. So let's say write sine of this angle. Sine of pi by 2 minus theta, that is going to be d by under root of a square plus d square. So because what we have now got sine of pi by 2 minus theta, that is what cos theta. So we get the value there also. So equating both these things. So what we have, a square plus d square sorry, upon 2r, that is equal to what I have, d upon under root of a square plus d square. So doing this, what I'll get, r is equal to a square plus d square upon 2d, and r is what, mv by qb. Mv is momentum, so now momentum you can see qb by 2 a square by d plus d. So go for option A, that coming out as correct. So it's not an easy one, it's a tough one for you. Next one, aeroplane diving at an angle of 53 degree with the vertical releases a projectile at this altitude. The projectile hits after 5 seconds the speed of the aircraft is. So it releases. Releases means its velocity is same as velocity of the aeroplane. It is at 53 degree with the vertical, let's say like this. So the velocity, let's say v. So the vertical component would be v cos 53, that times t plus half gt square, that is equal to 730. That is what I can make out. So v cos 53 is 3 by 5, t is given as 5, half g is 5, t square is 5 square, that is 730. So what do we have now? 3v plus 125 is 730, so 3v is 730 minus 125, that is 605. So v is 605 by 3, so approx 202 meter per second, I can make it out. Next one. Next says, a man of mass 60 kg climbed down using an elevator. Okay, the elevator had an acceleration of 4, acceleration due to gravity is 10. The man's apparent weight on its way down is, so on way down is, let's say it's basically lift, you can imagine. So because it is going down, the pseudo force would be acting upwards. Ma naught plus n would be equal to mg. So what I have, ma naught plus n equals to mg. So apparent weight is n, which becomes mg minus a naught. So this becomes what, 60 into what I have, 10 minus 4, that is 6. 60 into 6, that is 360 Newton will be its apparent weight. If it were to be going up, it would have been g plus a naught. You know these things, very common questions. Next one, if FPP, FNN, FNP are nuclear forces between proton, proton, neutron, neutron, proton, proton respectively, we know the nuclear forces between the particles is independent of the charge, it will be same. If it would be a net force, then the answer would have been different, because there you have to take the electrostatic forces also into account, which you don't need to do here. Next one, body is doing SHM with an amplitude and frequency, the maximum velocity, though this is an easy one for you, yeah. V is omega A, that is 2 pi f, 2 pi into 15 into 0.06, 15, 6 and 90, so 1.8 pi that you get, and 1.8 pi is approximately 15 6 and 90, 90 into 2, 1.8 pi. Yes, this is 1.8 pi, so this is definitely going to be less than 6.28. So only this option I think is appropriate, so no need to check acceleration also, you can directly do this here. So that's the way T. This is an easy one, it should be doable to you. Uniform electric field, uniform magnetic field exists in a region in the same direction. Electron is projected with velocity in the same direction. The electron, we have done this before. Because this is the velocity, this is E, this is B. B will exert no force, and electron, because it is electron, the force due to electric field would be opposite to it. So electron will be not be deflected, but speed will decrease. We are taking the case till it decreases, not when the direction reverses, then, because then it will start to increase. Okay. Terminal velocity of a spherical object varies with radius. You directly remember Vt is proportional to r square. So r square curve you know is equal to a. So again a very easy one for you. Next one. What is the angle of incidence for an equilateral prism of refracting index √3 so that the rays parallel to the base inside the prism? That means it is talking of minimum deviation. So it is talking of minimum deviation. So what we have for the minimum deviation, you need this like, or for this also you can directly do. So this angle is I, because it is 60 degree, and this will be 6 no, sorry, this is parallel, so this is again would be 60 60 that you will have, you know this. So this angle is 30, so 1 into sine I should be equal to √3 into sine of what? 30. Sine of 30 is what? Sine 30, write me like this. So √3 by 2 sine I, so you all know sine I is √3 by 2 for I equals to 60 degree. So it's an easy one for you. So this is sine I equals to √3 by 2. Okay, next. A sphere of mass m and radius r rolls on a horizontal plane without slipping. I actually forgot to take this screenshot. This is somehow missed, so I have to take from the explanation part. A sphere of mass and radius rolls on a horizontal plane without slipping with speed u. If it rolls up vertically, the maximum height. You know, if it rolls up means no loss in kinetic and in any energy. So mgh would be equal to total kinetic energy, which we generally write it as half mv square beta. And beta for solid sphere is 7 by 5. You know that's factor beta 1 plus k square by r square we use. That would be 7 by 5. So it is 7 by 10 mv square equal to mgh. So now you can make it out. The height would be 7 vu square by 10 g. Go for option C. So it's an easy one. Or you can do the both kinetics. You can add half mv square plus half I omega square like thing. The last one, this is again a repeated one. Everyone knows when it is forward bias, this current will flow and voltage appears. When it is reverse bias, nothing appears. Go for option A. So these were the physics question for today. Now we are, as I told you, because I'll do some more questions. Yesterday I didn't did but I'll do here. The splitting of spectral lines under the influence of magnetic field, that is what you know as Zeeman effect. That is common to physics and chemistry. That's why, and it's an easy one for you. Now next I have is question number 12. At low pressure, the van der Waals equation is expressed as. So what happens at low temperature? The basic equation is P plus A by Vm square into Vm minus B equals to RT. You know this. Now what happens? You are given at low pressure. So because pressure is low, so what we can have, this factor can be neglected, but this has to be added because pressure is already low. So what we have, P plus A by Vm square and approximately Vm equals to RT. This is what we get. So now what we get, PV max plus A by Vm equals to RT. So the Z what we Z if you write, so Z if you write, this is what. So now Z is what you write typically as PVM upon RT. So if I do that, PVM upon RT, so PV upon RT would be equals to 1 minus A upon VM RT. That is what you are getting. So what we are getting, the option D. So this is the 12th question. Typically not physics part, but you can take it as a guess, which is true for internal energy. You know, internal energy is a state function. That is the most important thing. It is not a path function for sure. Next, what we have next is the 43rd, the last one I am taking from chemistry. Calculate the work done during isothermal expansion of 1 mole of an ideal gas from 10 atm to 1 atm at 300 Kelvin. So because all options are negative, we need to only check for the magnitude. Don't go for any convention or something. So because it is isothermal, our formula is an RTLN V final upon V initial or P initial upon P final, whatever you can write. And what we have, one RT is 300, ln of P initial upon P final, that is equal to ln of 1 by 10. So 300 R and minus ln 10. ln 10 you all are aware that is equal to what we have, that at 2.303 factor that we typically write. So 2.303 into 300 R. So R is, if I write it as 25 by 3, which we generally write for physics. So this is 100, 2500 into 2, so to 2.3, so that would be 5700 something. So we'll go for the option C, that is the most appropriate one. So instead of 45, I have solved 49 for you. Keep sharing this channel. Thank you.